Hey everyone, how are we doing? Everyone having a good day? Mubot's already in the chat. Mubot, what are you doing here, Mubot? I'm gonna destroy Mubot. What does that do? Save preset. Oh, that's cool. Maybe that's an update to the bot. I didn't know it. How is everyone doing? It's not so distracting when this background breaks. You might not notice it. Oh, just destroyed Mubot. What's up, Trace? Good to see you here. What work are people doing? What work do people have right now? Let me bring back up. People have been meaning to respond to. God, I told one person I would look at it after class. Look at their assignment. Haven't done that yet. Got a meeting here, another meeting. So yes, I could go look at it right now if you want. Can we go over the first two homeworks due Monday for 474? I'll start looking at that right here. If you want, if you want, I could look at someone's thing. They said it was this morning. I'm reactive. Do you mind if I look at someone's reactive right here real quick, Trace? I'm gonna look at someone's reactive. I'm gonna reply to them because I meant to. They were, I think, one of the few messages I didn't get to this morning. I've kept it up. That way I don't lose it. Please, if I don't respond to you, be like, hey, Brian, I'm just wondering about this. If it's been like 8 hours, especially if I said I would respond, because I might have clicked on it and forgot. So I'm going to do that really quick right here. I'm going to look at someone's reactive. Yeah, let's do that. Let's look at a reactive right here. Okay, let me look. So I'm going to have this up in the background right here. Okay, let's take a look and see what's going on here, because I feel bad when thank you so much, Trace. Positivity, Trace, right there. Let's throw out. Do I have the points still saved? No, I don't have the points saved. Let's throw out some 50 points for the positivity right here. Okay, so I'm going to apply to them on Discord. Let me get this working right here. Okay, they're saying they're having problems with the reactive objects. So the reactive objects are going to allow us to kind of... Hey, Brian, could you open up cutting out on canvas? Oh, is it not open, Philip? Sorry, Philip. Did we talk? Did you fill out the form, Philip? Did you fill out the form? Let me see. Tuesday, I'm going to do this real quick right here. You might have emailed me, and then did you fill out the form? Did you email me? Sorry, like I should have made clear to people like to also. Let me double check. We talked on Discord. Okay, let me just open it. I'm sorry, without the form, I did everyone on the form. Okay, let me get this fixed up. We're just fixing everything as it goes. Philip, 2 seconds right here. Let me give you your time. Thank you so much. I lost my work. Look like if you don't use Shiny... If you don't use Shiny and submit it, it can just be a file. It can just be a file. You can submit work that shows your coding knowledge. It'll be graded on how well you can show and explain the basic models and the parameters. So you're basically just looking at creating an RMD and knitting it. It'll be based on how well you can show the basic concepts of what you're learning, and it'll be graded out of 90 to start. So let me get Philip started up right here. Sorry about that, Philip. I probably told you were good and everything. I was just going off the form right here. Let me get that fixed up right away. So Philip, you're going to be starting here in 5 minutes. And then I'm going to take a look at the app right over here. Thank you, everyone, for swinging by. And thank you for just contacting me right away. Then there's an issue. Say, hey, Brian, I thought we're going to do this. You said this, Brian, but you didn't do it. Let's go and take a look. Yeah. Oh, we don't. I will post those. Great question of who right there. Sorry for the delay on that. I will post those. Those should be appearing this weekend. And it was Philip. Okay, Philip. Here we go. And so you'll be starting here in 5 minutes, Philip. As long as that's okay with you. Be like, Brian, I'm at work right now. Awesome. Sounds good. Good deal. We'll get you started up here. And oh, it's your time. Oh, no, this all is your time. So I gotta tell me if there's an error because I'm doing your time. So here we go. Sorry, no. Okay, your time. Wait, that's the start available. And then we need to go here. Your time. Tell me if a time is wrong. 3:35 your time. 3:35 your time. Okay. Tell me, Philip, do you see everything? It should be open for you. Everyone gets the same window right here. Make sure to record. Philip, how's it looking? So make sure if you go see it, kind of hop out of all this, close everything down, have ready to record. Philip, how you looking there, Philip? Everything should be good to go over there for Philip. And then we will have the solutions posted this weekend. Sorry for the delay on that, Ahood. I will post some solutions for that. I'm going to go and grade those this weekend. Everything should be all caught up. This weekend had the big shock to the system with the tooth exploding. So kind of really took off Wednesday night after that. Didn't get some work done. It is available now. Awesome. Close everything down. So Philip will be leaving us here. Hop in, make sure you're screen record all the way through the whole process. So make sure to be showing it right there. You got this, Philip. Positivity right there from Jacob. Love the positivity. You're welcome, Mahood. Thank you so much. Everyone's so nice to me. No one's mean. One time a student was mean to me. That wasn't nice. Okay, let me see. I'm going to work on the person who sent me their code first. We're going to hop to Trace's questions right here. So we're working on a little code in the background right here. Who says you can't do office hours online? Talk to students personally. That's a lie. You can talk to students. Let's go, Philip. You got it, Philip. You might not be here anymore. Probably isn't if he's starting the exam. Okay, let me see. I'm trying to fix something for someone on Discord real quick. They say it's the reactives, they're saying. Okay. Plots required, but I'm noticing none of my graphics change when I change the data. The frequencies have to be reactive. Yeah, so let me see if there's a frequency button. I can create the reactive frequency right now. Okay, so there is a frequency button. Let me see where the frequency input is. It's probably called frequency. I'd be shocked if it's not called frequency. Okay, here it is. It's under frequency. So now we want to go and see where the input frequency is used elsewhere. That's why we use normal naming conventions. Oh, there it is. I see the issue. You sent a picture of this too. Okay, so what'd you call the time series on this? There's the time series. Oh, no, you do have the input. Oh, wait, but you're doing it right here. But the input frequency. As numeric frequency. No, it should be. I think you are intaking the frequency right there. I think the frequency is being used. If the person knows who I'm talking to, then. I'm going to add in a plot to this because I think your frequency is being used. The date is a little bit more complex. You'd be surprised how. If you don't get the date working, it's not the end of the world. So your app might not be perfect. That's all right. There's a lot of hurdles for this. I'm going to take a look at your chat here in a second. Sorry if. Keeps me out of the app. Hey, Brian, could you get something weird on the Shiny app? Could you check it out? If you break your Shiny app, it'll say nope. So always keep your most recent version working. We'll listen to one more song here. I should have this fixed up here. I'm going to send this back to someone because I think their frequency is working. Let me just look at their app again. You're just watching me in space right now as I try to fix this right here. Okay, they are showing the models. This is looking pretty good. The person probably knows who I'm talking to. This is looking very good. Individual who messaged me on Discord. Yes, type to me on Discord if you want it. You can type to me in chat if you want to. But this is looking very good. I'm looking at your app. I'm watching your app right here. I'm going through it. Yeah, you're basically on the ending of your app. Like you've got what's needed. I'm pretty sure you've got seasonality in this. I'm gonna throw a page on here. I'm pretty sure you got seasonality. So I'm adding a page to yours to show that we do probably have your seasonality, and then I could talk to you more about getting the date object is pretty annoying. The better way to enter in the date, and you might have done it, is to do different boxes on the date. I've gotten it to work with the date, but it's easier if you just do like a year entry, a month entry, a day entry. So suggestions for 475. If you do the year entry, and I'm actually just watching the Discord now, it's the best way to ask questions via Discord. Kind of personal questions, you can always ask them in the chat. And right now I'm not looking all through Discord. I'm just trying to, I told this person this morning I would help them out. And then I want to kind of throw them the help here since they asked like early thing in the morning. I'm going to see if I can get this going right here. I'm going to send you back because I think your seasonality is working. Your reactive object is data. Oh, wait, let me see where you're using it as a time series. You're saving it. Okay, it is data. It is data. Your reactive object is data. Okay, I think you have seasonality in here. Tags HR. Just don't want to break anything. I want to send this back to you, not broken. Okay, good. Oh, no, that's the wrong spot. Ah, so many spots. You want to get good at something, do it 100 times. You want to get amazing, teach it. Okay, so I'm adding a seasonality page to yours right here. It's going to take plot output. I'll be doing more general help in a second here. Page is going to be called seasonality. What I call it down low, season. think I've got this. If you have seasonality, this should work. Did I do it? Answer is... Autoplot requires season, requires a TS object. It's not taken as a TS object right now. You are using TS objects, though. For point 4, are we doing a prediction window for the main plot? I was a bit confused. The prediction window is also for the base models. Yes, use a prediction window going forward with the H. So to Abby's question right there, you can ask questions in the chat. Use a prediction window going forward with the H. And currently, I'm seeing where you stored the time series model. Another quick song right here. Data 1. Your data 1 is time series. Okay, I didn't use the right data. That's why it didn't work. Okay, please work. It said it didn't have a data time series object. Autoplot requires a TS object. Is it not? Your rendering plot right here. Render plot. Autorema, data time series. Data stored into there. Let's take a look. Your time series object is tripping me up. Don't worry. Don't worry, though. It's very, very close. It's... The scan-in file part of it is interesting. If you want to type to me on the... You getting the same error? I can take a look. Message me as soon as possible on these things. I basically do things in order they arrive. Like the workaround on this might be a tiny bit bigger. Let me see if the GG season plot is working. If you ever want to see if something is working, you just take something very basic and you make sure it's running with something that should run with it. And it's giving me an error there. I think it's because it doesn't have it loaded in. Oh, that's doing something right there. Okay. If you ever want to see if something's working, I'll hop over to the main screen here in a second. But if you ever want to see if something's working, put something in there that should work. And if the thing that should work is working, so your Rema's doing it, your check residuals is working. So where are you grabbing those objects? Because those objects are working. Okay, let's just do the same process right here. Let's just take and do the same exact process, but do it over here and see if you have... I'm just doing the same process you did, going by what your code structure is. Yep, it works now. I just did what you were doing, and it works. Your seasonality is there. Yeah. And the seasonality is not changing. And so you are correct. Unless we load in a different data set. It might be doing it for the data set. 2 seconds, I'm going to hop to main questions. So it looks like there's some errors going on right here. I might take a bigger look at this. It's been working awesome. I might take a bigger look at this. I'm going to close it down for the moment. I'll come back to it. It is, I was able to add a season plot to it, but you are correct. I think it's the way you're reading in your time series object. You're using, let me look at the way the function, I'm going to have to unravel this function a little bit. Because you're doing the TS scan. This is the input of the TS. Where's the TS end? Frequency as numeric, input frequency. And so you've got all your inputs. It might be just getting mad and tossing things out. What we should do is let's remove out parts. And let's just see if the frequency... You know what we're going to do? We're just going to set the frequency equal to something like 12. And let's see if that changes it, to see if it's just interacting with this or if it doesn't like the value. It's not using it. It's not taking it in. So what I would do... I think I see where the error is. And so try this out. Currently, you're doing the conversion of... what you're calling it data 1. I think I see part of the issue. I think I see part of the issue. Your data is different. You call data 1 up here, but then down below you're calling it data. And the data object is the read in data, but then you have a data 1. So you have 2 reactive objects, and the data never becomes a time series object. So down below is lost. I'll come back. I might have to come back to this. Data 1 is the time series object, and data is not the time series object. So there's 2 more seconds on this one last song right here. Data 1 is the time series object. Might be it. It's not doing it right now. It looks like you have a data and a data 1 for coding night. No, don't have a scratch sheet. No scratch sheet. No scratch sheet. No scratch sheet. Clear desk. You can have as much R open as you want, so you can take notes. What's up, the real AJ? So good to see you. Helping out a person with their coder here. I will come back to that. I might try and narrow down the error a little bit more, but it looks like it's data and data 1, so just trying to get the hang of someone's code right there. Let's go ahead. We're going to open up a new assignment. So good to see you, AJ. 50 points. AJ hopping in the chat here. Just helping out with some coding right there in the background. So let's see right here. I think it was someone was asking about the next assignment for 474. Please send me your questions as early as possible. I'm going to go around and run some errands later today. Maybe get a haircut. This haircut's getting crazy. But please send me questions as early as possible. The closer it is to the due date, the harder it is to answer because a lot of questions start coming in. So it's very, very hard to debug or change things. And I only make these changes for you in little bits of changes. Let's go ahead and take a look at the clustering. Clustering is due on Monday. Let's see where we got to see if we need to reorient the due date. We might be moving the due date. Just got to look, see what we covered, see where we're at. Okay, we're hopping into some clustering right here. Let me open the window back. Okay, here we go. Covering some material right now. And so good to see you, AJ. How you doing, AJ? AJ took... Did you take 320 or 201, AJ? Which one? I think 320, right? Let's hop over to the main screen. Let's do this. AJ, summer going pretty well. Are you taking classes? Did you graduate? Which question were people wondering about on the new homework assignment? The new homework assignment, you go to the first 2 on the homework due Monday. Let me see where the end of the homework goes to. Using the aggregate, find the average value of each column. We can do that right there. Going right here, find the dendrogram. I think we might be moving this to Tuesday because dendrograms we did not cover today. Dendrograms are super cool. We did not do a dendrogram, so let's go ahead and make the executive decision right now. Homework assignment for 474, move to Tuesday night. It does make next week a little bit quick when it comes to Tuesday and Wednesday assignments, but we're now moving it to Tuesday, so we're not covering this on Monday because we will be covering dendrograms on Monday. So let's go down here and take a look. Okay, so what do we have right here? Use the data homework 6 to answer questions here. Let's go ahead and make that. If you notice what we're taking, we're just taking what's of Survey 9. Boo, Survey 9. Survey 9 is going to be what? These are the what's we're taking of Survey 9. And then we're assigning some column names. What are we getting for data homework 6? What have we created? We've created our own data set. And what do we have right here? It's kind of a what of, there's probably better ways of doing this. Talk about, while people are wondering what this is right here. If we were to go to Survey 9, showing some new code. One of the things I don't like with this keyword, select. And is it not in dplyr? So many options in dplyr. Select columns. No, data table. For some reason, I'm trying to think. What is the select? Wait. Nah, it doesn't work. It's not filter. Is it filter? No. Can't remember my dplyr. We were basically making a subset, and you could subset do that. It's select in subset. The argument in subset is select. So you could achieve this same goal right here by going to subset. Survey 9 says select, and will not let me do it without conditions. Maybe it doesn't. Really? Really? Is my brain just not working today? Weight greater than 190. How am I losing my mind today? Undefined column selected. Oh, there is no weight column. Survey 9, I don't like you. It is called x03.weight. And now we have a subset. And we should be able to, theoretically, there we go. So it's because, and we're basically doing this right here, and we're taking things like GPA. With this right here, we're just taking multiple columns. And so we could do the same sort of method right here to subset columns off. I've sent you my RMD file. Yes, send to me as soon as possible. I'll look at some errors over this. If you notice right here, we're just subsetting. This is what data homework 6 is. It's the same sort of idea. But guess what? Everything is better names. Better names, good. Awesome stuff right there. So using data homework 6, we know what we got right here. Always investigate what you have. Better names for columns. We like it. And K means clustering. We need to scale the variables first. What does scaling mean? What does scaling variables mean? You can always do this to see what you're going to make. What does scaling variables mean? Very important thing we talked about a lot today. What does scaling variables mean as my R tries to load this in the background? What does scaling variables mean? So we need to scale them. Turn them into what's? If we are scaling variables, we are turning them into what? Now it's like a Word document. Just like a Word document. Z-scores, great job, Ahood, right there, 20 points. We're turning them into Z-scores. So we want to say, well, these need to be Z-scores now because we need everything to be on an even playing field. That's why we're standardizing them. From the summary, data homework 6, which variables, list 2, will dominate the distance measure if we do not scale them? Well, let's not do survey 9. You know where we're going with this. Let's do some survey 10. So survey 10, I'm using survey 10 right here because I don't want to do your exact homework assignment, but the answers are probably going to be pretty similar. We're going to load up survey 10. Once again, remember, Brian does similar, not exact same work as you. Once again, Brian is doing similar, but not the same work. We're going to make a sub 10, and the sub of survey 10 is going to be the variables right here of columns 2 through 5 or 6. Why not? There we go. So now we've got a subset of survey 10, and it's a similar thing going on right here. What variables do you think would dominate the scale right here? What variable do you think, just theoretically speaking, would not dominate the distance matrix? There should be one that stands out as like, yeah, the differences there are going to be very tiny, where another one should have a high domination of the distance matrix without the scaling. Pre-scaling, what variables, and we haven't summarized it, but if you look at the variables right up there, there should be at least one that's going to be like, the differences there are going to be very tiny. It's not going to dominate the distance matrix pre-scaling. And then the larger variables, like what do we mean by larger? What do you think? Which ones are not going to dominate the distance matrix? Good old summary function. So which ones are not going to dominate the distance matrix? Clear the screen. Do it again. Boop. Really? Don't increase font? Okay. There we go. Which ones will or will not dominate the distance matrix? GPA will not dominate the distance matrix. Great job, Mubarak, right there. GPA is on such a small scale right here that differences in GPA are tiny. But imagine someone told you they had a difference of 4 in their GPA, and you'd be like, did you have me get 4.0 and the other person made 0? Like, yeah, I have a difference of 4 on a 4.0 scale. And you'd be like, well, that's ridiculous. That's the biggest difference possible. But a difference of 4 in text, how many times you text per day, which somebody texts 1,000 times a day. How many seconds are in a day? Oops, why are we not down there? We got our... There are that many seconds in a day. This individual is texting Sigh. Not that. Yeah, they're texting every minute. But you're probably not awake for that long. Okay, they stay up late at night. Yeah, they're texting every minute. Okay, you could text 1,000 times a day. A little less than every minute if you sleep 6 hours a night. I gotta get my texts in. Sadly, 10 years ago, I would have been like, that's ridiculous. And now I'm like, someone's probably texted more than 1,000 times a day. So here's the variables. We see that this will dominate the distance matrix right here. We're going to see the weaker components. I wish I could color code these. Yeah, let's color code these, Really? In terms of what will dominate the distance matrix, without scaling, pre-scaling the variables to put them all on the same playing field, the variables with the wider range are going to have a bigger impact on the distance matrix. So the ones that are really not going to impact it right here are going to be like this. This is in like its own, whoops, wrong one. This is going to be a very weak variable, not really giving us distances between things. And then we've got our moderate, probably right in here. It's moderate. Then you've got your high, both of these, and they're very similarly scaled because they both are about weight. So they have a similar sort of structure to their range and minimum max range. But then what we have right here is, oh no. And maybe due to the outlier and stuff like that, especially the outlier is going to create a lot of differences between individuals. That one's kind of unique in the outlier sense. The other variables might have some more symmetry to them. We could plot them and take a look. But definitely minimum impact on distances, moderate impact, large impact, and probably a large impact, but also an outlier that's causing some interesting effects. So that's the whole point of why we scale stuff. It's going to put everything on the same playing field. We might even be able to do it pretty quickly. Let's try some cool codes right here, and then we'll look at the question. So I think that should answer pretty quickly what's going on there. You just got to look at your data set and understand the theory behind this. So probably, I wonder, should work in theory. Did it? Yeah, it did. Yeah. We can scale all of it right here, and then we can summarize it. I wonder if this will work. And the answer is, now look at it. What do you notice about the summary once we've done the scaling? Oof. And yeah, that person is pretty weird. Now, you do see some interesting structures to this, especially with this outlier over here. This was our 1,000-person text per day. What do you see interesting after we've scaled these using the scale function, which will turn them into z-scores like that? What do you notice? This person is still having a large impact. They're super weird. We might actually want to know if it's a valid data entry point. It is theoretically possible, and I was doing some data validation right there to be like, yeah, I guess maybe they were just ahead of the time in 2010 texting that much. They're like, one day people will just text all the time, and I'm going to be like them. What do you notice all these values are by scaling them? Very important thing that we like to practice. We make sure we know that all of these scaled values here are whats. Every single one of these scaled values is a what right now. Every single one of these scaled values. It's weird that this kind of goes from -3 to almost +3. -2 to +4. -1.6 to 4. -5 to 1.3. It doesn't have to go to certain values. It's just that everything in here, anytime you see something is a what. And we definitely have some symmetry issues here. Definitely have some symmetry issues. All of those values you are seeing, and I want to test something. All of those values you are seeing are simply z-scores. So every single value you just saw on the screen are all z-scores. And I'm pretty sure, and I love this, a new package we talked a lot about in time series is a package called, I'm going to load it up, ggally. I think this is the one I want. It's ggpubr for publishing. ggpubr. This is for publishing stuff and making stuff really easy to use. And so it's got some really amazing functions in it. I want to show you why this is amazing. I love displaying graphics. And with this library right here, ggpubr, it's for ggplot. If we have people's heights, which is one of our variables, and we want to look at the distribution of heights, the best way to look at heights is probably going to be with a histogram. So we could look at just R histogram. Like here's a basic R histogram. Nice. But if you want to make ggplot graphics, it's a little more complicated where you have to ggplot it and you have to do geom and all these extra things. You got to add on all the geom elements, the geom histogram, and you're adding on all these things and you're adding in the aesthetic. I thought of this and then someone did it. I was like, what if somebody just put, and they said, why not we just go here and go to gg histogram, which is what they made, and you put in the variable and then it makes it for you. But what's even better is, and I wish they just added an argument to this, is we go here to ggplotly, one of my favorite things that someone ever created. You can throw it inside of this, and you get a plotly object. We can make this look nicer, and I don't know why it's been doing that lately. You look into that. But this is now a plotly object right here, and a lot of these arguments work the same way. So we can see right there the distribution of GPA. We can see GPA pretty quickly, and GPA does have this right skew to it. We could add in a main title right here. We should be inside of the geom histogram. And we can go right here to main. I think it's main. No, it's title. We looked at this yesterday, I think. Equals histogram of GPA. We should see the title appear above it. There it is right there. Nice and neat, easy to use. But the problem with a lot of these variables that we're looking at in this data frame, let's take a look at our variables again. We are not seeing symmetry in our data. So one could argue that we might need to transform these variables due to the outliers having undue influence on the z-scores. That is an argument to be made. We could transform them, especially with some little bit of bimodality right here, because if you turn them into z-scores, it doesn't change the structure of the data. Looking at the scaled values, you see how it looks like this right here? We'll show the two. Notice how that doesn't change. It just takes, and what is the z-score going to do to it? Turning these into z-scores will do what? Let's see for 50 points if anyone knows in the chat. Turning these into z-scores will move the what of the distribution and change the what of the distribution. And here's what it's doing. You can see it right here. It's moving the what of the distribution and the what of the distribution. It's a re-something and a re-something of it. You can see where this is at right here. Trying to draw where the middle of it is at. So that's the middle, not the term we usually use. And here it is now. And then also this area down here has changed. So what is turning these into z-scores doing? It's not reordering the data or kind of like reshaping the data. It's not it is transforming it to a degree, but it's not structurally changing the differences. It's changing the center, which is the mean, and it's changing the standard deviation, which is the spread. And everything by doing a z-score loses its original mean and standard deviation and gets set to a mean of 0 and a standard deviation of 1. Now, it's just because of the right skew here that we don't see our classic -3 to +3 ratio. If the variable was more normally distributed, which I'm trying to think if any of these variables are normally distributed. I don't know if we have any that are. If the variable was more normally distributed, yeah, Mary, let's do that here next. You got it. Thank you, Mary, for asking. That's a great question. And we're talking about some normally distributed data. You bet, Mary. If we had more normally distributed data, this would go from -3 to +3. And as we've covered a lot in 201, we only use z-scores properly when it's normally distributed. But z-scores are going to help us remove the large effect of outliers here. So as we were saying, if the data has extreme values, which we see, let's remove the scaling on this. If the data has extreme values, then the distance matrix would be dominated by things that are really large in scale. Like right here, the distance matrix would be dominated by these people who have a lot of text differences, but meanwhile, the GPA of this person with a 2.8, probably me, and I'm not joking, probably me, and this person with a 4.0, these differences right here are much grander than the difference of people right here who have a difference of like 36 or so, 36.45 or 26.45 in their text per day. These are pretty largest differences where this, although numerically smaller, is going to be not taken into account until we scale those differences. By scaling the differences, these people are now z-scores and everything's put on a same playing field. Mary, thanks so much. Let's hop over to Mary's question. Let's do the waiter waitress question. Here we go. Waiter waitress question. This is on the sampling distribution of the sample mean Let me get my Pearson pulled up. 2 seconds here. Hopping over to my Pearson. My Pearson. Logging in. Chapter 14, correct? Sampling distribution of the sample mean. So this new test starts talking about how to handle quantitative data. And that's actually what we were just dealing with right there, was quantitative data. I promise you, if you ever go to, which many people do, we had people today talking about, I was in Stats 1 such a while ago, Brian, and they were talking about the class they were in. As you go to upper levels of these classes, the concepts we talk about, like we were just talking about z-scores. And so we continue to talk about z-scores. Someone in 474 said, do we have to know how to find a z-score? And I said, yes. I said, it's super important. Finding a z-score is very important. And then I cried. Let's go talk about that waiter waitress. Here we go. Waiter waitress problem 4201. Waiter waitress problem 201. So here we are on the waiter/waitress problem. It really depends on what kind of version of the question you get. It just changes sometimes. There we go, waitress. I think it used to not change, but I'm glad it changes. Good stuff. We actually got one of the easier versions of the problem. Let me explain why. There's a few things we need to understand for this problem. One, you have to put yourself in the position of this waiter/waitress. When you wait tables, you get different tips. I know I'm shocking you with that. But maybe your tip will be small, maybe it'll be big. But on average, and you must work at a fine dining restaurant, on average, you get about $9.60. Does that make sense? You say like, man, I've worked for a long time. I've looked at my average tip. Usually make about $9.60. But with that, that'd be a great place to work. We're back. Sorry, a little buffer right there. I agree with Jacob. Man, I wish I worked at a place where I was getting close to $10 tips. This is the what in your tip. So like, imagine, and I can show this right here. I'm gonna show it in R. Don't worry if you're watching this for 201. I'm just gonna show you what it would look like. It's like to say, and this is what's so cool. We'll go to a new sheet. Let's go to random normal, and we're gonna generate 1,000 tips for you with a mean of 940 and a standard deviation of like $4.80, was it? $4.70. So we'll just call these tips. And we can use our same code from before. Watch this. We're just going to grab this really cool code we got right here. And we're going to bring it up to here. And we're just going to put the tips inside of here just so we can see it. Just so we see what we got. Histogram of tips. And I want you to look at your histogram of your tips. Now, you can't get negative tips. But what is the 4.7 controlling? And I want you to look at the code, or not look at the code, but look at the histogram. And the 4.7 was changed to 1. And what do you notice about the tips now? What is this 4.7 controlling? Just use a general word that, look, now it's back to 4.7. Here's when it's 1. And look at the data right here. And here's where it's 4.7. So 4.7 is not the center, which is 9.60. 4.7 controls how far what, because now it's 1. 4.7 controls what the data is from the mean of 9.6. This value right here, if we bring it back to 4.7, you can see how the data looks, and it goes on a much larger scale, or like it's more what over the data, or the length of the data. It's more what out. 4.7, which is the standard deviation of what we get on tips. Like we usually get about $10. Sometimes we get a little bit more. Sometimes we get a little bit less. It's kind of rare we go down here, I guess. If you wait tables and you tip out, you might get a negative tip. Like if someone leaves $0, you might have to tip out. You might actually be losing money. I guess we had a big fine diner here and they didn't give us any money. We had to tip out $6.50. So theoretically possible to get a negative tip when waiting tables. If you've had to tip out, waiters probably know that term. I've waited tables. The 4.7 is controlling the spread of the distribution. So you're not always going to get $9.60. You don't always get $9.60, $9.60, $9.60. It's just you get $9.60 on average. So when we think about this for this problem right here, we're then going to wonder, we want to make $500 this weekend. So our goal this weekend is to make $500. We'd say, I really need this $500. And we are going to say, our place says to us, you are going to wait on 50 parties. We got 50 parties signed up and you want to make $500. So first question to ask yourself, let's bring the problem over to a page right here. How much do you want to make on average? Now listen to what I'm saying right here. It's It's where it gets a little interesting for this problem. How much do you want to make on average? Who knows in the chat? How much would you like to make on average? You have $500 you want to make, and you have 50 tables. How much would you like to make on average? Like, what would you like your mean tip to be? What would you like the mean tip to be? Like, on average, the mean tip we would like to observe is what? I'd really love for a mean tip of this. And we'll talk about how we found that, because yours might not be as nice as my numbers. You're like, I really need $500, and I've got 50 tables to make that on. I really need to make this per table. So think if you have $500 you want to make, 50 tables you got to make it on, how much would you need per table at least to make this goal? What do you think? You need $500 for some reason, and you got 50 tables to make it on. Yeah, I really need to make this amount per table. Per table, I got to make at least this. I got to make at least this per table. So we got $500 we got to make. Great job, Mubarak, right there. Great job earning everyone some 20 points in the chat right there. We need to make $10 per table. Awesome work. And so that's just obtained from how much money we want to make, how many tables we got to make it on, and that's going to be $10 per table. That is how much money we need to make right there. So with this right now, we know the average tip we need. We know up top the distribution of single tips, and this is where people usually get confused on this chapter. Well, our average tip is going to have less variation in it. It's like if I were to talk to one guy and I say, how tall are you? He says 6'3", and I'm like, it's kind of tall. But then if I were to talk to 100 guys and they were on average 6'3", that'd be like, whoa, those 100 guys right there are on average 6'3"? That's more unusual. Think about when something happens repeatedly over time that's above the mean, that wouldn't be expected. Because when we average this out, we get a new distribution, and this goes to the central limit theorem. I could cover that right now if anyone wants. The central limit theorem says that the distribution of the mean, not single observations, is going to be tighter and more normally distributed as n gets larger. Big topic right there. So our new distribution is going to be an aggregate of the old distribution we just drew out, but the new distribution is going to be tighter and more normal. These pens and Word drive me nuts. So the original distribution right here is normally distributed. This is single observations, like one tip, the one we just saw in the background on R. One tip will have a mean, so it's going to have a mean, and it's going to have a standard deviation. That's just the one tip, which we see up above. These are the values here and here. But the new distribution of the mean, and this is what would happen on average as we take the mean, would have a mean. Words are not nice to me. There we go. Let's see if that works. Would have a distribution right here that is normally distributed. Since the original one was normal, the aggregate of it will be also normal via the central limit theorem. And the center of this distribution will be, wait for it, the mean. It's like saying, I expect one guy to be 5'10", so I expect a bunch of guys to have an average height of 5'10". Because all you're doing right here for this distribution is taking points and averaging them. Now, it is theoretically possible, totally possible, that random points could be obtained down here, and then the average of them would be down there. Stop it, Microsoft Word. So we could theoretically land far away, but on average, which is the mean of this distribution, taking random observations of single points and then averaging them out would on average land around the center, on average, not in one instance. The standard deviation is where the change happens, and you can see that. You can see visually speaking right here that the standard deviation has gotten smaller. And the more samples we take, the more we're kind of averaging things out towards the center. So the equation for the standard deviation of the new distribution is sigma, the original standard deviation up there of 4.7 over the square root of n. So our goal right here is to find these values. This is the average tip on 50 tables, not one tip. We're saying we want to know we make at least $10 on average. So because our goal is to talk about the average tip we get is more than $10. So what probability do we have of getting an average tip, not a single tip, of more than $10? And to do this, let's find these numbers. Well, we just take 50, and let's bring the calculator to the main screen. The square root of 50, and I'll write this down here on the bottom. Let's write it into the equation. The mean is the mean, which is just up there. It's 9.60 dollars, so let's do that. And this is square root of 50. You're so mean, Microsoft Word. And 4.70. These values are being obtained up here for the mean and the standard deviation of the original distribution, which are the same values right here. But down on the bottom, we have to do sigma, the original standard deviation, over the square root of n. Because it's getting tighter, because we're averaging together values, because it's a mean, it's on average what we would see when we take a sample size of 50 tables in this instance. And so now we're going to get these values for the distribution. 9.60 is easy. And we're going to go here and put in 50 square root. Copy that. 4.7. Oh, it's going to be like 0.1. I can't do math. It's 0.6646. There we go. And let's take, and just remember this value, I've copied it, and we need our old friend, Mr. David M. Lane, some stat 201, 32474. People are like, I know about some David M. Lane. The reason we do this right here is because we don't expect you to go to Z-tables on the test. People don't really use Z-tables anymore. They used to be in the back of books all the time, and then I ripped all of them out, and they don't exist anymore. No, they exist. I just don't like them. It's much more exact to go here to a distribution calculator or to do things inside of R, which is probably how I would do it, but we don't do that in 201. And we can go in and we can put the mean of the distribution and the standard deviation. So we have here the mean is still just the same value of the mean of 9.60 right there. The new standard deviation is the value we just calculated on the calculator with the mathematics shown right here. So let's go ahead and put in the mean of 9.60 and the standard deviation. Now I know where this problem's going, so I'm going to do something. I'm going to put it under both fields just to help myself out in this moment. This one moves it down slightly, and I put the mean and standard deviation there because I know the next portion of this problem. But for the moment it asked me, remember this is the distribution of the mean now, not of a singular table. So we would expect on average on 50 tables to make $9.60. What's the probability we get $10? Well, it's somewhere at a z-score of about, because that's how many standard deviations this is above the mean, of about 0.6. Now you could z-score it, but the good news is we don't have to because this can find the answer for us. There it is. And that's a z-score probably about 9.6 or 9.7. And if you use the z-score, you'll need to use the standard normal curve with a mean of 0 and a standard deviation of 1. But I call this the in-context curve because that is the sampling distribution of the sample mean, and we can see the probability down below. It also goes by the rule constantly that 68 would be in the center, 32 would be outside, and 16 would be above 1 standard deviation. So 27 kind of makes sense for this number right here for the probability. Let's cross our fingers. Hope we did it correct because I have made errors. We have an error calculator for that. 4 decimals, you don't say? Check answer, excellent. Woo, give myself a heart attack right there. The next question asks a little bit different of a question. It now wants to know how much you make on your best 1% of weekends. Now, what we're viewing right here is the best 27% of weekends. Like 27% of the time, waiting on 50 tables, we would get a tip of $10 or more and obtaining $500. Now, do remember, these are our best weekends. So a lot of people get confused when they go over here and they look at the best 1% of weekends, which would be on the top side of the distribution because you want to make money. Someone could say, well, my best weekends are when I don't make money. Okay, then I don't know, someone's going to email me that. I don't want to make money, Brian. Those are my best weekends. Well, okay. You didn't make $11.14.6. I'm going to pause here for a moment. This is your what tip. Let's see if answer in. I'm going to give out 100 points if someone answers in. This is not your tip you made on the best 1% of weekends on 50 tables. This is your what tip, because remember what this distribution is. It's the sampling distribution of the sample mean. This down here, this $11.14.6 is not the tip you made on the best 1% of weekends. It's the what tip. 100 points on the line right here. Who knows? It's not your best. It's not your tip. This is the sampling distribution. Kind of move Archer on the right track. This is your what tip for the 50 tables. And expected is kind of a very close word. It's Bingo, Jacob. Great job, everyone right there. It's your average tip because this distribution is a distribution of means for 50 tables. So this is your, I'm doing 200 points. I really appreciate it. Some people practicing some 201 right here, just remembering the ideas of the central limit theorem. This is not a singular tip distribution. It's what we would expect to see if we had 50 tips. For those who took 201, so let me just, before I ask the question, and I'm showing everyone here. So this is our average tip on 50 tables. So on 50 tables, we would make that amount. I times it by 50 because that is how many tables I was waiting on. And that was my average tip. And it should be right. It is done. Let me hop here to the top screen and let me ask a big question. Did anyone take 201 here and maybe hearing this again? Like, you might even remember that problem. My Pearson problems haven't really changed much over time. But maybe hearing this again and hearing like what that distribution is, and we're looking at a distribution of average tips. So this is saying like the context of that is on 50 tables, this is the best 1% of tips we would get on average. So if that's an average tip for 50 tables, how much money did we make? Hearing this again, did it maybe make some more sense? And this is why I always say to people, you have to like learn things 3 times sometimes. And then it starts to stick and you're like, oh, it makes sense. And I understand, I can break it apart. Imagine if your friend was like, I'm going to teach you how to like build an engine. And they walk you outside and they're like, okay, it's going to take 3 hours. Do you think 3 hours from then you could build an engine? Do you think they could explain it in 3 hours? Probably. But I don't think it would stick in 3 hours. 100% true, yeah. And maybe coming back to it then, especially for, because we got some 474, 475s in here. And these are complex things. They're complex things right now, and they're complex things in 201. Central limit theorem is a huge backbone of a lot of statistics, but you have to hear these things 3 or 4 times. That's why, just remember this. I saw a meme one time and it made me go nuts. That meme had so much impact on my life. It said something like, remember, every doctor you've ever gone to was cramming the night before their exams too. They were probably cramming, like going over it a 5th time. Probably some genius doctors who kind of cakewalked through med school and were cramming the night before. Maybe not even cramming. They would just like open the book before the exam and be like, put it in my head, I've got an eidetic memory. But in truth, a lot of the people who are really successful are the ones who start early, work hard. I know that's like our theme, and it's like just like, well, yeah, Brian, everyone says start early, work hard. But as soon as you start to get that practice down, like I've just seen it, and I'm very proud of many individuals, and I'm the person who was not doing this. So I'm speaking to past Brian. I'm not trying to be mean to anybody. It's just like I want to go back to past Brian and reach through time and be like, you gotta start early, Brian. You gotta do work. You gotta ask questions. So Mary and Mubarak and Jacob, thank you. But there's a lot going on in the world today. A lot going on in the world back then. For the parts that say interpret the summary statistics in chat for the seasonality, what expect you're looking for the 475. I sent you my shiny app in Discord if you want. Yeah, I'll take a look in here in a little bit, Jacob. We might hop off here because we've got a lot to take a look at, I'm sure. Discord says 9+. They should have it go up to 99+. Maybe I can change on the icon. There's really some flexibility in what I'll accept. Like, the better you interpret it, the better. I've been watching what people have been doing. I mean, some people there's like 4 different tiers of work of what I'm seeing. What do you think about giving us more time? We're calling it tonight. Because some people have structured. I understand, Ahood. So whatever you have tonight, turn it in. I hate to say this. I've learned this. And I've heard this from students. Like, especially if you have a big thing like this and you're like, you get, like, I'll extend things usually earlier on, especially if we don't get to material. The issue is some students might have structured their time around this, like maybe taken off work. And then students have said to me, hey, Brian, you know, if I did it at the start of the week, yes. But this early, this close to the deadline. Sorry. Thank you for asking. Thank you for asking. 20 points for asking. Thank you for asking. Always ask. But in the past, I've done things like that. And then I'm very proud. Students have told me, hey, I took off work on Friday night. And I would have worked because I needed to make money. And, you know, you extended it to Saturday and I wasn't, you know. No, but good question. Good question. Awesome, Mubarak. Great job, Mubarak. And this is a tough assignment. Keep working on what you have. Keep asking questions. Focus in on little things. Don't try to do too much. Don't try to immediately do too much. And we are in the final periods of work right now. There is going to be the final, and that's an opportunity to improve. Probably going to hop over to Discord. I'm going to get some food or something. But don't worry. Keep up the hard work here. There's going to be the final. Yeah, no. I'm throwing another 20 points. I always want people to ask. You never know. I said yeah. I mean, I didn't. It'd be great if it's a text output. It'd be great if it was. You could just throw in an RMD if you want. I am looking at what people are doing. I'm not going by the highest level. I'm not looking at the top tier one and saying, I'm seeing what people are getting done. I'm seeing what's possible. And that's why I didn't go hard on the assignments. See, Hayden's got one. I think Jacob's got one. So I'm going to hop off here in 1 minute or so. But I didn't go hard on the homework assignments this week because I wanted a lot of focus on this. That would be amazing. That'd be amazing. Jacob, if you know printf, if you know that sort of stuff, that'd be amazing. If you have a static page, that's all right. So if you look into doing a conditional text output, that'd be great. You don't need that. I can give some ideas over there, but if you know, one group especially did it on their first. Did I post theirs? I need to post the apps. But one group was using the printf function to pull the reactive. It's not really a reactive object, but they're pulling the values that are being created. Yeah. If you know that and you got that because you guys had the page with that, yeah. If you just want to pull that and do that, since you've got that skill set, that's gonna make it really nice. I'm not gonna be. It might be. I'm not gonna be like. There's just certain levels of work I want to see. I want to see the graphics working. I want to see that you turned it into a time series. I want to see you have some interpretations. I want to see you have forecast periods. I did a long if statement that included stuff pulled from the summary. Yeah. If you want me to give you advice, I've frankly just told a few people to stop. I've had a few people who started really early, have made some really great stuff, and I've been like, you have 100. Like at this point, you have 100. So it's really great to see what's being created. But all those people I've told to stop hit hurdles. Maybe not all, but a lot of them. I can automatically think of a few. I've been like, oh, you're good. Stop. I don't say it like that. I'm like, you got 100 if you turned it in right now. Like, because this is more than what I wanted. But they all were hitting hurdles and asking questions from the very start. So remember, 5 minutes stuck, ask a question. Especially right now, it's going to take a moment. How many messages do I have? Let me see. Not that bad. Okay. Well, I'm going to let everyone go here. Grab a little food. I'll be trying to get to as many messages as I can. We'll be back here in a little bit. Well, tomorrow? Next week? I don't know. Be back. Puppet Shark. Bye, buddy.